Sorry about this. Okay. Hello, everybody. Thanks for being there. I know it's the lunch break, so thanks really for being there. So my name is Arthur. I'm a product manager at Linea. And so like today, I will be talking about ERC-3668. So yeah, let's get started. Basically, the agenda is quite straightforward. I will explain what it is, why do we need it, right? And how does it work, the use cases behind it, and I will spend some time talking about the cool integration that we did at Linea to benefit from this standard. So maybe to set the context, let's just talk about how we can access external data. I think most of you knows, but natively, right, a chain cannot access data from the external world, whether it's over chains or the web. But like over the time, we built some other protocols that solve those problems. So the main one are bridges, right? If you most known to if you want to bridge assets, so coins, NFTs, but there are also message bridge that let you send a transaction on chain A and it executes a transaction on chain B. There are also oracles that are well known for like price feed mostly, but most recently, they have creating more generalized implementation, such as like chainlink functions and other. And lately, we have also coprocessors that are enabling those kind of use cases. So the question you might ask yourself is, okay, why do we need another solution? And basically, ERC-3668, also known as CCIP-read, was a standard proposed by the ENS team, especially Nick, because they had like unique use cases where they wanted to access the information for L2, especially for managing like domain name with cheaper like gas cost, but they have some constraint and the design is reflecting that. So the first benefit is that it doesn't require any transaction to send on chain compared to all the other solutions that we mentioned. So this is more efficient in a way if you don't need to store the data on chain because you don't have to pay the gas cost. You also avoid external dependency on external protocols because it's an ERC and it's like on top of the protocol but doesn't have those dependency and external additional trust assumption as well. So let me tell you a bit how it works. There is three parts to it. It starts with the client, and here we are not talking about execution client or consensus client, but more like the UIs or like backends that are calling the blockchain. And like the client will call a smart contract, right? Standard if call to get some information, something that happens quite generally. And the main part of the design from ERC-3668 is this allows the contract to revert with an error that's basically tell the client, actually you need to give me a bit more data so that I can do my job. So at this point, so the client will add the job to fetch the data on a gateway, so a standard HTTP call, and of course the gateway will send the result, and then the client is like giving back the information to the contract through a callback function. And at the end of the day, you have an answer. So here I talk about call, but actually the callback function can be also sent in a transaction. So that means that at the end of the day, you have some logic that can be executed on chain in a block. The nice thing about this design is that if you look at the off-chain data error, there is all the information stored on there to explain to the client what he needs to do. So in advance, the client doesn't need to have any information about what are the gateway to call, what is the information that I need to send to the gateway, which is the call data, or what are the callback function, and so on. So this means that the client can have a standard implementation and you don't need to integrate each time like a specific use case. So if you want to integrate like a chain like, I don't know, Optimism and a chain like Linea, you don't have to do it twice. So if you are following like attentively, you might ask yourself, but okay, like it seems that you have to trust the gateway, and like thanks to during the introduction, we said it was like a secure and trust minimized way to fetch data. And actually, you don't have to trust the gateway necessarily if the gateway provides also proof of the information that were given. And the nice thing about it is that you know that L2s, like in the design of Rollup, are posting their state on the layer 1, and so you can like just fetch a storage proof on the L2, and then like verify it on the layer 1 so that you can be sure that the data is accurate. So that's what is shown here. When you are when the gateway is doing the HTTP request, actually the gateway will call a L2 RPC, will ask for the information through an if call, and then also like do something like a if get proof to get the storage proof. And then when the contract receives the information, it will call the rollup contract, which can verify the proof at a high level. So I think like the design is quite cool, but what can we do with it? As mentioned in the introduction, like ENS was the one proposing it, and actually they had a very specific use case in mind, which was to enable to manage like domains on L2 for cheaper like gas cost, and that's the main use case that we are seeing today. One example is the Linea names that we introduce on Linea, where you can have like names like brian.linea.if or arthur.linea.if. It's something that we built and that can be reused by like the ecosystem to build any integration with ENS, and it works like everywhere ENS is resolved. As an example, like we have an NFT collection on Linea which are called ifrogs that wanted to give a ENS domain to all the holders. So for instance, now if you have a you type 743.ifrogs.if, it resolves to the owner of this NFT, and if the NFT is transferred, like the name is transferred with it as well. So this is kind of cool. But it's just a first use case, and it doesn't stop there. Like it can be used for any type of use cases where basically you want to either compute or store data on the layer 2 or even off-chain and access it on layer 1. So some examples include like DAO governance, where with solution like, like governance solution like SnapshotX that are providing like voting on chain, you can vote on Linea or over L2s that are much cheaper in gas, and then you can just take the result and call this result to execute transaction on the layer 1. One other interesting use case, for instance, is to like gate access to smart contracts. So for instance, like if you are doing an airdrop or NFT mints, you can require people to have specific credentials that are minted on layer 2 in attestation, for instance. So, okay. You might ask your question, how do I need to implement that? It seems really complicated. You are talking about proof and so on. The nice thing is that we already implemented all the smart contracts. So like all this complicated logic, or not so complicated, but all this logic is already taken care of. We have a gateway that is running. We have all the smart contracts, the ones that are verifying the proof, which for ZK rollup is especially difficult because the ZK layer 2 usually have a different way to store data because like the standard hash function can be a bit complicated for ZK. So for instance, on Linea, we have like sparse Merkle tree instead of Merkle tree. But basically, all of that is to say that we have contracts that are open source and that can be called to verify the data, to also fetch the data directly. So basically, on the smart contract level, it's much more simpler. And on top of that, there have been teams like the Unruggable team that have built additional layer of abstraction that simplify it even more and abstract the chain so it can seamlessly work on different chains. So to summarize the benefits, ERC-3668 is efficient because you don't have to send a transaction on L1 when you don't need to. It's secure, especially when you are working on a layer 2 with zero knowledge proof like Linea. You don't introduce additional dependency to other protocol, and the development overhead is minimal because all the contracts, the gateway, everything is already for you to build on. And so if you want to get started, those are some links to our docs, documentation, open source repo. But most importantly, we are doing a workshop just after the lunch break where we will deep dive into really code example, and you will be able to have a live version running on your laptop at the end of the session. So yeah, that's it. Thanks a lot.
Just a reminder, guys, if you guys have any questions, you can ask them through Meerkat, scan the QR code. Looks like we already have some more coming in. The first question, is it possible to read L1 data from L2?
So yeah, in theory, it's totally possible. Like ERC-3668 allows to fetch any data. The only thing is that you need to have the state of the blockchain that you want to query anchored on the chain where you want to, from which you want to, sorry, I will go again. But you need to, on the blockchain that is querying the information, you need to have the state of the blockchain that is being queried. And so it's not, most rollup doesn't have that at the moment. Maybe at some point we will see Oracle that are streaming this kind of data on chain. But it would be something really cool to build.
The last question we have, doesn't it make the process more centralized?
So indeed, the point of centralization here is the gateway. But if we come back to, okay, actually the smart contract can pass multiple URLs. So you have a kind of redundancy here because you can have multiple different gateways, not to rely on a single point of failure. But since the gateway is passing a proof, it cannot be tampered with, so there is no additional trust assumption regarding the accuracy of the data.
We have another question. Keep them coming, guys. We still have time. Does it open up to a temporal attack if the L2 storage proof is not posted on L1 yet?
Yeah, that's a very good question. So you are aware that L2s are not finalizing every second or minutes on L1, and so basically you don't have the state of L2 before it's getting finalized. So on the ZK rollup, it can be from a few minutes to hours, depending on the layer 2s. On optimistic rollup, it's the 7 days. So this means that you need to wait this period in order to fetch the data. So there is this latency, but as the space evolves and we are going to faster finality, hopefully this will get better. I don't think there is an attack. It's just that the client and smart contract need to be aware of this limitation and work with it at the moment.
What libraries already implement this behavior?
If.js for sure, WAGMI as well. Unruggable is creating a higher level abstraction to work across chains, so you don't even have to worry about the specific of the each gateways and so on as a builder that wants to rely on your own gateway. Those are the libraries I know.
Is there any network latency when reading data?
So yeah, it's the finalization latency. So as I mentioned, like from a few minutes to 7 days if you're on an optimistic rollup. But like from the network latency, really, like it's really quick, like usually less than a second or even less. So you can test it and like type, for instance, like arthur.linea.if on your MetaMask or on the ENS website, and you will see like the answer is almost